Magical Makers, it's Professor Gallagher. Are you ready to become wizards of wiring? Well, we'll take our first step along this journey by learning about the ultra-easy-to-use STEMMA-QT and Qwiic standards. This standard lets us access devices that use a communication mechanism known as I2C. Newbies, don't be intimidated by the geeky acronyms. It's actually pretty easy. And while I'll start by demonstrating the MCP9808 temperature sensor, in later lessons we'll use this setup for all sorts of additional electronics, including a time-of-flight distance sensor, a multi-sensor with gesture input, and a 12-pad capacitive touch sensor. And in this lesson, while we're at it, we'll also take a moment to demonstrate some additional techniques for number formatting in CircuitPython. Are you ready to expand your knowledge? Then let's wire up for big learning. Now, I know you want to get wiring and programming, but if you're going to be working with Maker Electronics, it's important to take a few moments to talk about the STEMMA-QT standard and explain what it is and what it isn't, since it's really easy to confuse terms, and with just a little bit of intro knowledge, you can avoid some of the common errors and pitfalls that have frustrated many a newbie maker. Now, this is a really easy-to-use connection scheme that will allow you to simply plug in devices to the board using a standard connection cable. Sometimes you'll hear add-on boards like this referred to as breakout boards. Now, STEMMA-QT devices use a communication standard called I2C. That's just a communication standard between boards and add-on devices. If you're curious, it stands for Inter-Integrated Circuit, and it's usually written as the letter I, the number 2, and the letter C. Now, most microcontroller boards support I2C. I2C is considered to be one of the big 3 microcontroller communication protocols. The other 2 are SPI or SPI, which is popular for connecting certain types of displays, although there are some basic black and white displays that you can connect via STEMMA-QT, and you might also hear about projects that use UART. That's popular with MIDI devices and GPS work. And while an increasing number of boards have a STEMMA-QT port built in, unfortunately there's not one built into the CircuitPlayground boards or the Raspberry Pi Pico boards that my students are using in their course. So if your board doesn't have a STEMMA-QT or Qwiic port, then to use I2C you have to hook up 4 separate wires for power, ground, data, and clock. Then once you have a STEMMA-QT port, you can plug in any STEMMA-QT breakout boards with this one connector that brings together all 4 wires. And not only can you plug in the devices with this cable, you can also daisy chain devices together so they can all share that one port. Now, STEMMA-QT is Adafruit's name for this standard. SparkFun calls the standard Qwiic, that's Qwiic. The IIC stands for I2C, and SparkFun's Qwiic standard only supports 3.3 volt devices. The Adafruit STEMMA-QT standard is a little more flexible. It supports 5 volt as well as 3.3 volts. Now, if you want to use a Qwiic breakout board from the SparkFun company and you want to use CircuitPython, just make sure that there's a CircuitPython library to support that device. Also, even though this STEMMA-QT connector is really handy, it uses the I2C communication standard, and not all the things that we want to attach to our board use I2C. For example, if you want to hook up some hardware that we used in our previous lessons, like the NeoPixel light strips and strands, or the servos and potentiometers that we'd used in our CPB lessons, these don't use I2C, so they don't link directly to the STEMMA-QT port. A dead giveaway is that these devices used 3 wires, while the I2C standard that STEMMA-QT uses 4 wires. Now, one other thing that's easy to confuse, there's another standard, actually 2 standards called STEMMA, not STEMMA-QT. There's no QT at the end. And this system is not plug compatible with STEMMA-QT. And it gets even more confusing because the STEMMA standard has 2 different kinds of connectors, a 4-pin and a 3-pin standard. Now, here's what you need to remember. The 4-pin STEMMA standard is compatible with STEMMA-QT because both of these standards support I2C. You can use the STEMMA 4-pin with STEMMA-QT if you have a special adapter cable. And there's also a 3-pin STEMMA that's not I2C devices, so it doesn't work with STEMMA-QT. Now, if this is confusing, just make sure that you buy breakout boards that are specifically STEMMA-QT with a QT at the end if you want them to work with the standard STEMMA-QT port and the standard STEMMA-QT wiring. I've made the mistake of buying devices that were just STEMMA devices and not STEMMA-QT devices, and they didn't work with the port and wiring I wanted to use them with. So now that you're armed with some basic STEMMA-QT knowledge, let's build. First, let's add a STEMMA-QT connector to our CircuitPlayground. I'm using a Bluefruit, but it's the same procedure for a CircuitPlayground Express. Now, fortunately, the STEMMA-QT wiring standard is pretty consistent. You should clip the black cable to any ground, the red to any of the 3.3 volt pads, blue, which is SDA or the data cable, to pad A5, which is also labeled as SDA on CircuitPlayground boards, and yellow, which is SCL or clock, clips to pad A4, which is labeled as SCL on the CircuitPlayground. Now we're going to be using the inexpensive yet precise MCP9808 temperature sensor. Now there is a temperature sensor built into CircuitPlayground boards, but that sensor is mounted on the electronics, which do heat up. It's not especially accurate, so if you were going to be creating a more true to climate sensor, this sensor, with a cable kept apart from the electronics, would be a better choice. So with your STEMMA-QT cable clipped to your CircuitPlayground, either port of the sensor will do, the little metal bits on the cable point down, and always grab the plastic plug, never tug the wires because those can be a little fragile. Then plug your board into the computer and open PyCharm. So working with the MCP9808 is super easy. We just import the Adafruit _MCP9808 library. We'll use CircUp to do this in a minute, and we'll also add the library to our PyCharm project so we can take advantage of code completion and error handling. Now this library is also going to need the Adafruit _register library, but CircUp will handle all of that. Then we declare an I2C object. If you have a CircuitPlayground, Bluefruit, or Express, you do that with board, dot, and with capital letters I2C, followed by empty parens. And just so that you know, later when we use the Pico, and with most boards that have a built-in STEMMA-QT connector, the setup is just a little bit different. It's board, dot, and in all caps, STEMMA _I2C with parens. Then we'll create a temperature sensor object. We could call this anything, but here I call it temp_sensor. I think that's a good name. And this is created by using the Adafruit _MCP9808 library and dot the MCP9808 class in that library. And here we pass in the I2C object that we just created above. And that's because the MCP9808 is an I2C device. And that's it. We're all set up. Then we just refer to the temp sensor's .temperature property to get the temperature in Celsius, and this formula here will convert that value to Fahrenheit. We can print out both the Celsius and Fahrenheit values and repeat this every 2 seconds. So let's give this a try. And if you're new here, welcome. You may want to check out the earlier lessons in the playlist so you know how we got here. So PyCharm pals, since we're using a new library, let's add this to our PyCharm project. Head up to the settings menu and under your project, with the Python interpreter selected, click on the plus icon, search for MCP9808. Remember, the official CircuitPython libraries are the ones that start with Adafruit-CircuitPython, so select this one, then click Install Package, then click Close, and OK. And let's make sure that this library is installed on our CircuitPy board. So we'll head to the terminal. At the prompt, we'll enter circup install Adafruit _MCP9808. That's all in lowercase. Press return. CircUp does the installation. And we can close the terminal and begin coding. So I'll put in a comment that we're working with the MCP9808 temperature sensor. Then we need to import 3 libraries, board, time, and Adafruit _MCP9808. Then we create the I2C object with I2C equals board dot, in all caps, I2C, open and close parens. And I'm going to name my temperature sensor temp_sensor. Set that equal to Adafruit _MCP9808. That's the library we just imported. And then say dot MCP9808. That's the class we're going to use. MCP is capitalized in the class. And to set that up, in between parentheses, we pass in I2C, the I2C object we just created. I always like to put a print statement before my while true, so I'll say print sensing temperature. Then in our while true loop, I'll create a value temp C to hold the temperature in Celsius equals temp_sensor.temperature. Then we'll convert that to Fahrenheit and store that in a value called temp F, and that'll be equal to temp C times 9 divided by 5 plus 32. That's just the standard Celsius to Fahrenheit conversion formula. Now in this next line, we're going to print out the temperature in degrees Celsius and degrees Fahrenheit, but I'm also going to show you how we can format so that we can print out our numeric values to a certain number of decimal places. Now from our earlier CircuitPython school lessons, we learned about f-strings. We can precede the double quotes of a string with a lowercase f, then use curly braces inside the double quotes of a string. And we can fill in those curly braces with a variable or expression. This is going to create a string that takes the values from these variables and makes them part of the string. So for example, here we've got an f string with 2 sets of curlies. The first one gets the value of temp C, the second gets the value of the variable temp F, and the result we get is this string down here with the numbers indicating our 2 temps. But inside the curlies, we can also insert special codes to format our data. These codes are called string format specifiers, and you can search for that online if you'd like to learn more about these codes. And here are 2 of the more common things that you might want to do. So if you want to format a value so that only 2 decimal places show, like you often want to do when you work with currencies, and inside the curlies, you follow your variable or expression with colon, followed by a period, followed by 2 for 2 decimal places, and then a lowercase f, which means we're going to be using floating point values. Floating point values are values that can have decimal places.
Or if you wanted 1 or 3 decimal places, you could change the 2 to 1 or 3. Or as you see below, if you change the number to 0, we don't have any decimal point, let alone values to the right of the decimal point. And down here, I also point out that if you cut a value short by formatting, it's rounded. So 0.5 or above will round to the next highest value, otherwise it rounds down. So let's try this out in our code. So we'll print an F string with print, and between parens we'll say F, open and close double quotes. Then inside we'll say temperature, colon, open and close curlies for the first value. Then I'll type degree symbol F. To type the degree symbol on the Mac, it's Shift Option 8. On Windows, it's Alt plus 0176. You don't have to put the degree symbol in there. It's a nice thing to do. Then I'll say comma, space, open and close curlies for the second value in my F string. I'll follow that with degree symbol C. Then in the first set of curlies, I'll enter my value temp F. In the second set, I'll say temp C, but then I'll add my format specifiers. So after temp F, I'm going to say colon, space, dot 1 lowercase f, so that's going to format any decimal to one place. And just to try this with a different number of decimals, after temp C, I'm going to say colon, space, dot 2f, and that'll give me 2 decimals for the Celsius temperature. Then I'll add a time dot sleep, passing in 1.0 to wait 1 second between each temperature reading. Then let's save this and take a look at our results. So it looks like it's 69 degrees in GeForce Labs. Let's pick up the sensor and see if we can warm things up. So I'll put my thumb right over the sensor, and we can see the temperature is going up quite a bit now that I got my thumb on that. I'll take my thumb off. Let's try to cool this down. Now let me get out this mug of ice water. This is my mug from UTS, University of Technology, Sydney, where I taught on sabbatical. Miss you, Aussies. I've got to hold it for a while, but we can see the temp should go down even more. So, all right, our sensor is working. Congratulations, coder. And once again, the big learning was both hot and cool. We learned about the STEMMA-QT and Qwiic standards and how these differ from other standards. We connected a STEMMA-QT cable to a CircuitPlayground. We used the MCP9808 temperature sensor in CircuitPython to show both Celsius and Fahrenheit temperatures. And we learned how to use string format specifiers and F strings to print values for a specific number of decimal places or no decimal places at all. I hope you're enjoying the big learning, coder. We're going to do a lot more with STEMMA-QT, so make sure you got that down and stay cool.